Welcome, my radio listeners, to What Class Is This? Your host, your teacher, Mr. O, talking to you from Radio TCS Channel 115. Good morning, geometry. Today, we're going to be looking at section 12-4, Similarity in Right Triangles. Again, our EQ today is how does the altitude to the hypotenuse of a right triangle help you use similar right triangles to solve problems. So again, section 12-4 is another section that deals with triangles that are similar and how to find a missing side. Okay, so I think you'll like this section. Now, the first thing I'd like us to do is I want you to take a moment and do the explore A through F and then reflect 1, 2, and 3. So I need you to do is pause your video, do that, and come on back. All right, if you have worked that out now, here's what it's about. So the explore part is asking us to take a right triangle. Again, I took the time and made one myself. Take a right triangle and letter A. We know that this is a right triangle because we indicated it has a right angle, and also we know as a more just additional information, we know the side opposite the right angle. This is called the hypotenuse. All right, so now what they ask you to do in letter A is make 2 copies, which I have. Choose one of your triangles, and I happen to choose one of them. And I happen to just take the page and folded the one side over till this side is lined up to the side of the triangle, and it connects over here. So all I did is I just folded it over like this. And by doing that, you'll be able to see from letter B that this guy, right, this part right here of the fold, that is your altitude. Now that has some significance when we get into it. Then they ask you is to take this triangle right here and cut the second triangle along the altitude, label it, which I didn't do, and then all I wanted you to do is they wanted you to answer the next questions of the Explorer that deals with these 2 triangles in relationship to this triangle right here. And you were supposed to see something. Well, what were you supposed to see? So let's go ahead and answer those questions. So again, question D is asking us place triangle 2 on top place triangle 2 on top of triangle 1, and what do you notice about the angles? And you will see that the corresponding angles are congruent. Again, you should know what that means. I shouldn't have to explain that. Letter E, what is true of triangles 1 and 2, and how do you know? Well, we know that they are congruent, and they're congruent by the angle-angle similarity criterion, which we did in a previous section of chapter 12. Letter E is asking you now to repeat steps 1 and 2 for triangles 1 and 3, and they're asking the question, does the same relationship hold true for triangles 1 and 3? And the answer is yes. The corresponding angles are congruent, and the triangles are similar by the angle-angle similarity criteria. Then in the reflect, all they're asking you to do is asking some simple questions that deal with it. Again, what you can do is go ahead and pause your video, write that down, and then we'll go to the next section, next part. Okay, and we'll see how this is applicable to the next section, or to this section. All right, so we are back. Now let's go to page 665. And page 665 deals with what is called the geometric mean of a pair of numbers. Again, I want you to read that, take the time, think it through. It is really easy. This stuff was, this type of a proportion was dealt with in the last section, so everything in here is just going to be relatively mostly math. All right. So I have worked out problem. Letter A is already worked out for us, but I want to work out letter B. And I'm going to go and do it, add some stuff to it to help you guys out. So again, we want to find the geometric mean between the number 9 and 20. Again, the first thing we'll do is we'll set up the proportion. We have 9 over x equals x over 20. Again, the next thing that they did is again, they showed it a little bit different here. So I'm going to set it up for you guys. Here's where this first step is. And in doing these problems, you just do cross multiplication. Cross multiply. And we know that 9 times 20 is 180. And x times x is x squared. Again, I'm doing this a little bit different what they show here. Again, we want to find out what x is, so we have to get rid of this square. To get rid of a square, we have to take a square root of both sides. Again, we don't have to do the plus or minus for this situation because it has to deal with a distance in this situation. And what what we want to do next is we want to simplify the square 180. Now again, that's what I put it over here for Otis. So it's very simple, okay? We can simplify 180. Again, once again, I'm doing this without a calculator. So what you need to do in doing this is we got to look at 180 and we have to ask ourselves what factor of 180 will be a perfect square. So you got to think in your head perfect squares. Once again, 1, 4, 9, 16, 25, 36. Those are all examples of a perfect square. So again, we notice in this one, we know that 36 times 5 is 180. Okay? So again, if you look at it, the 36 here is a perfect square factor of 180. And with that said and done, we will have this set up right here. And we know from just this part right here, we know that the square root of 36 is 6. And whatever's left over stays in the radical. So that right there will be the geometric mean of 9 and 20. All right. Now, do me a favor, pause the video and try your hand at the problem, the your turn number 6 and 7. All right, we are back. Same thing again. Here we want to find the geometric mean of the numbers. If necessary, give the answer in simplest radical form. So again, number 6. Again, I don't show the setup, but if you need to see this setup, here it is. 6 over x equals x over 24. Cross multiply. Or in this case, they just set up by just going 6. They just want 6 times 24 equals square root of 144, which is 12. Okay. Number 7, the geometric mean is nothing more than the square root of 5 times 12, which gives us square root of 60. And again, we have to ask ourselves, what is a perfect square factor of 60? And it's going to be 4. And we know that 4 times 15 is 60. So we know that is the simplified form of this. Again, one of the factors of 60 is a perfect square. And then we simplify it, and we see we would get an answer of 2 radical 15. That all comes from the top of the page. All right, so what I want to do now is, how does that have to deal with this section? So what I need you to do is take a moment and look at page 666. and we will focus on the theorem at the top of the page. And this is the geometric means theorem. Now I'm going to let you guys peruse that. Again, once again, it is in orange, so you can have this information set up in your HD&Cs. You can have this and your diagram to help you do the geometric mean. All right. Now I think what we'll do for the remainder of this video is work out a couple of examples. Okay, see how it's done. So go ahead and pause the video and look at page 667 and go ahead and work out question example 3B. All right. Okay, you're back from the video. Again, here's question 3A. Using our picture, letter A is finding the value of x. Letter B is finding the value of y. And once again, the right-hand side is the work of A and B. I'll let you guys peruse that. So now let's go ahead and do step by step your turn number 10. So here is our problem. We want to find the value of x. We're trying to find him. So again, if you treat this like what was done in the explore part, we can set up our problem to be this. 5 over x equals x over 7. Cross multiplication. X squared equals 35. Solve for x, so we're going to take the square root of both sides. Once again, we know that 35 does not have any perfect square factors. That's just going to be 5 times 7. So the value of x, okay, in other words, the altitude of these two similar triangles, that's what this is, the altitude of these two similar, or actually the altitude of the original triangle, but applying it right here, will be nothing more than the square root of 35. Now also, major sidebar, remember Bob will have it as a radical, but some of you who are going to be using your calculator, which is okay, again, to find the square root of 35, you take your calculator out. Need to clear my screen. We do second square, type in 35, and we will get a decimal representation of 5.916. So we can leave it in to the nearest hundredth, and you'll get that answer as a decimal representation. All right, so section 12-4 deals with, all right, get your act together, Mr. Wakanish, deals with similarity in right triangles. How does the altitude to the hypotenuse of a right triangle help you use similar right triangles to solve problems? So now you have some examples to work out. My next video, I will take the time and work out a few others. I like to okay, what problems do I have set up here? Where's my notes? I have a few examples I want to work out. I'll have to go back and look at my sheet of paper, what I want to deal with. So, all right, that's the video, guys. Again, thank you so much. Again, this should help you guys out in section 12.4. It's not going to be that difficult. It's very similar to the last section. It's just now we have to deal with geometric means to be able to find one of our sides. All right, love you guys. Have a good time doing the homework. Catch you later.